Hi, have you ever heard about Google's data centers? They're quite unique compared to the usual ones.
Google's data centers. I'm intrigued. What makes them so distinctive?
Well, unlike conventional data centers or small server farms, Google's are built on a large scale and are designed internally by Google itself. This design allows for both unique challenges and opportunities.
Challenges and opportunities. How do they differ from the traditional data center setups we know?
In traditional setups, data centers might use standard technologies and infrastructures, but Google's approach is proprietary. That means they design their power distribution, cooling systems, networking, and even the compute hardware from scratch.
That sounds complex. What terminologies do they use? Is it anything like managing ley lines?
In a way, yes. They use specific terms to distinguish between hardware and software. For instance, a machine refers to a piece of hardware, while server is used for software that provides a service.
Interesting. So they keep the concepts of machines and servers separate for clarity?
Exactly. This separation helps in managing scales as big as theirs. It allows them to allocate resources efficiently, since machines aren't dedicated to specific server programs.
Ah, that's clever. By not tying down machines to particular software, they can optimize use and manage failures better.
You've got it. Plus, it helps maintain consistency in their massive operations. Once you're accustomed to their terminology, it's much easier to understand their system's logic.
And how do they ensure these data centers communicate effectively given the scale? Is there a system, much like how we maintain connections between different Inazuman isles?
They certainly have. They've developed a virtual switch called Jupiter to facilitate fast communication across the data center's machines.
Jupiter, you say? So it acts as a network, interconnecting all their hardware?
Yes, it's a vast network fabric supporting enormous data traffic across machines, ensuring smooth and swift communication, much like how a conductor synchronizes an orchestra.
Such intricacy. How do they manage this on a global scale, though?
Their data centers are interconnected via a globe-spanning network, allowing them to cover vast geographical areas efficiently.
Global governance in action, I see. Google's approach sounds as strategic as running a nation.
Indeed, but it's not just the scale, it's their strategic use of technology that ensures these data centers work seamlessly.
And the opportunities you mentioned earlier, what do those entail?
The opportunities lie in efficiency and innovation. With their infrastructure, Google can experiment and innovate continuously, much like we develop new techniques for battle.
Quite insightful, Hu Tao. Google's data centers truly seem like an engineering masterpiece.
Exactly, It's a combination of technical prowess and visionary thinking, forging a path much like our own adventures in Tevat.
Hu Tao, earlier you mentioned Google's internal designs for their data centers. Can you tell me more about the hardware aspects?
Of course, Google's hardware design is quite sophisticated. They tailor the power distribution, cooling, and networking devices specifically for their data centers.
Tailored designs, you say? How does such customization influence their operations?
Well, it allows them to optimize for their needs exactly. For instance, their power distribution is highly efficient, ensuring that their machines run smoothly without disruptions. Imagine a perfectly prepared battlefield with all resources in place.
I see, that sounds very precise. What about cooling? Consistent performance must require an advanced system.
You're right. Their cooling systems are customized to handle the vast amounts of heat generated by their hardware. It's essential for maintaining the performance and lifespan of their equipment, much like keeping a cool head in a heated battle.
And the network infrastructure, how do they manage such extensive communication needs?
The network is fascinating. They use custom-built switches specifically designed by Google to handle their unique requirements.
Custom-built switches? That sounds like quite an engineering feat. How do these switches contribute to their operations?
These switches form a network topology that integrates all parts of the data center. It's like how an electroculus network connects regions in Inazuma for smooth energy flow.
Interesting analogy, Hu Tao. Is there a broader network structure connecting multiple data centers?
Yes, it's called the B4 network, which spans across the globe, connecting many data centers together. It allows for immense data flow between locations.
A global network impressive. How does this B4 network differ from conventional ones?
Unlike typical networks, the B4 is software-defined. This means they use a central system to manage traffic flow efficiently, rather than relying solely on the hardware itself.
A centralized management system for such an extensive network sounds challenging. What benefits does it bring?
It optimizes bandwidth allocation and can adjust quickly to changing demands, ensuring all areas receive ample resources without bottlenecks.
How pragmatic. So even the smallest transaction is managed fluidly across this sophisticated setup.
Exactly. It's all about maintaining balance and harmony, much like strategizing between different elemental forces in battle.
Google's approach to data center networks seems both powerful and elegant. It reminds me of planning grand strategies for Inazuma, ensuring every detail is covered.
Indeed, their meticulous care and design reflects their quest for efficiency and reliability, kind of like when we prepare for any unknown quests in Tevat.
I suppose such intricate systems are essential to support their vast operations worldwide.
Yes, each component plays a role in the larger picture, an orchestration that allows Google's services to function with speed and reliability.
A true marvel of contemporary engineering, it seems. Thank you for the insights, Hu Tao. It certainly expands my understanding of how technology can shape our world, much like the changing tides in Tevat.
You're welcome, It's always a joy to explore such connections between worlds, technology, and our adventures.
Hu Tao, now that we've discussed the hardware and network aspects of Google's data centers, I'm curious about the system software that manages them. How do they keep everything operational at such an enormous scale?
That's where Google's system software comes into play, particularly a powerful distributed cluster operating system called Borg.
Borg? That sounds very technical. What role does it play in managing such complex operations?
Borg is like the command center for all the data center operations. It manages job scheduling, allocates resources efficiently, and handles any failures that arise.
Handling job scheduling and resource allocation must be quite a challenge at Google's scale. How does Borg accomplish this?
Borg operates by managing user jobs at the cluster level, ensuring every task gets the resources it needs. Tasks may be servers or processes like a MapReduce job. Borg finds where to run these tasks and monitors them continuously.
It sounds efficient. How does it address failures, given the vast number of machines involved?
Failures are inevitable, and Borg accounts for this by monitoring tasks. If a task malfunctions, Borg can restart it on a different machine. This fluid allocation ensures no single point of failure affects the entire system, kind of like using elemental reactions strategically in battle.
Interesting. And how do they manage storage for all this data?
They use several storage solutions. One of the primary ones is called Colossus. It provides a cluster-wide file system with replication and encryption, essential for securely managing large volumes of data.
Colossus sounds like a guardian for their data. Does it resemble any existing storage systems we might know of?
Indeed, it's similar to open-source cluster file systems like Lustre or Hadoop's HDFS, but tailored specifically for Google's unique demands.
And how does Google manage the network for their data center operations? Given all their data center activities, network management must be crucial.
Absolutely. Google uses a software-defined network to manage their hardware. This allows them to centrally control and optimize data flow, reducing costs and enhancing performance.
Centralized control sounds efficient. However, does this not pose risks if the central system itself encounters issues?
A valid point, EI. However, by using duplicated controllers for their networks, they minimize risks associated with a single point of failure. It's like having multiple team members ready to take charge during a shift in the battlefield strategy.
How well thought out. It seems Google has anticipated many possible challenges. What about ensuring network resources are used efficiently?
For that, they utilize a system known as the Bandwidth Enforcer. It manages and optimizes bandwidth allocation much like Borg does for compute resources. This ensures that network traffic flows smoothly, preventing bottlenecks.
Google's approach to both storage and network management is quite comprehensive. Do they deploy additional software to assist in these operations?
Yes, there's more to their system. They use other tools like a lock service for managing access and Borg for monitoring the health of their systems. These tools help maintain alignment and order, similar to maintaining harmony among our forces.
A complex web of systems indeed, finely tuned like a strategist's carefully laid plans. Thank you, Hu Tao, for these insights. Each component you've described highlights how much attention to detail and foresight Google invests in their operations.
Glad to share, Ei. Just like our adventures, there's always more to uncover in the world of technology, as each part builds onto a larger cohesive system. Shall we continue our exploration?
Hu Tao, you've shared such fascinating insights about Google's technical infrastructure. I'm curious now about how they approach software development. It must be just as intricate as their hardware, right?
Absolutely, Ei. Google's software development practices are designed to be very efficient, akin to how we might train to achieve mastery of our techniques.
And what makes their practices stand out compared to more conventional methods?
One key aspect is their development velocity. They have a comprehensive environment that facilitates rapid development and rigorous testing. This ensures high quality, as well as quick iterations.
Rapid development? How do they balance speed with maintaining stability and accuracy in their systems?
That's where their sophisticated testing infrastructure comes into play. They use build servers that can compile requests quickly, utilizing parallel processing in their data centers.
Parallel processing to compile software. That sounds resource-intensive yet effective. How do they ensure all the checks pass before deploying any updates?
Every proposed change, even something small, undergoes thorough review and testing. Tests run on dependent software to catch issues early, notifying developers if something might break.
Rigorous indeed. It seems they maintain a high standard, ensuring nothing less than perfection reaches their users.
Exactly. They even employ methods like push on green for some projects, automatically pushing updates to production when tests are greenlit.
Quite proactive. So how do they deploy these services within Google's vast infrastructure?
They use a shared repository approach, which allows engineers to collaborate seamlessly. This means they can address issues across different components swiftly, thus maintaining integrity while innovating.
Shared repository. That must foster a great sense of cooperation among their engineers, like a harmonious team working towards a common goal.
Exactly. They can fix problems in components outside of their immediate projects, increasing overall efficiency.
Ingenious. And you mentioned a Shakespeare service as an example of their deployments?
Yes, the Shakespeare service is a hypothetical example they use to showcase their ecosystem. It searches words in Shakespeare's works relying on multiple Google technologies.
How is it structured within their infrastructure?
The service has two main parts: a batch component that indexes Shakespeare's texts into a Bigtable, and an application front-end handling user requests.
A two-part system for efficiency then. How is the front-end structured to manage user requests?
The front-end processes user queries and coordinates with back-end servers to fetch data from the Bigtable. It operates continuously to cater to users in different time zones.
That's quite comprehensive. Managing such a global load must involve precise strategies like selecting the right number of tasks.
Yes, indeed. They plan tasks meticulously based on expected load and redundancy needs. For instance, they adjust task count based on peak query loads and distribute tasks across global clusters.
So they accommodate varying loads across regions with tailored task distribution. Efficient. How do they manage data replication in such cases?
To reduce latency, they replicate Bigtable storage in each region, helping with resilience and data access speed. They also selectively reduce redundancy, where cost savings outweigh risks.
Managing risk and reward. A delicate balance, much like strategic decision-making in conflicts. Their meticulous approach truly is commendable.
Indeed, Google's methods are a marvel of precision and adaptability, crucial for their seamless global service delivery.
Thank you, Hu Tao, for sharing this glimpse into the sophisticated world of Google's development practices. It's enlightening to learn how they harness such technology.
My pleasure, Ei. Understanding these structures truly enhances our grasp of the world's interconnectedness, much like our journeys in Tevat. Looking forward to our next exploration.